Welcome to Adventures with a Very Small Lathe. Today I'm making the first part of the watch faceplate. The plate itself is a round piece of steel about 9mm thick, 80mm diameter. It'll be mounted on a shaft connected to a base plate which mounts on the lathe spindle. The spindle is larger than would be ideal for a watchmaking lathe, which is why it needs to be spaced from it so that the mounting parts of the faceplate can go closer to the center than the main spindle diameter would actually allow normally. On the back of the base plate there's a 40mm bore, which is the register for mounting onto the spindle. This piece is about as large as it's possible to fit into a chuck on my lathe, so we're operating at the limits of what the lathe can turn easily. The piece has also been cut with very varied thickness across its diameter by the bandsaw, because I didn't align the stock with the previous cut. So I've got about 4mm of difference in the diameter, across the diameter between the thicknesses. This means the piece is very lopsided in its weight and the chuck will be very unbalanced, which for such a small lathe has quite severe implications for how much vibration it will create. The first few cuts, which will even out the thickness, are going to be very difficult to do, as the speed is going to be limited by the vibration. The centering in the chuck doesn't matter critically because the outside can't be turned during this pass until we have some way of chucking it up centrally, but it does matter for keeping the chuck as balanced as possible. A quick cutting speed calculation shows that for an 80mm diameter with the inserts that I'm using, the maximum cutting RPM is going to be over 2000. So that's going to be way faster than I'm going to be able to cut with a part as imbalanced as this. So the only limit is how fast I can get it to spin without the vibration being too much. I tried out how high I could set the RPM without the vibration becoming a problem, and the effect was immediately very obvious. The maximum I could set the RPM to without the vibration being a serious source of chatter was about 750. The first cut was pretty easy because the tool was only engaging with a very small proportion of the outer diameter, so there was very little cutting pressure. As the length of the cut increased, the cutting pressure meant that the spindle speed slowed down significantly, as at these speeds this lathe doesn't have very much torque. After a finishing pass, I turned the piece around and did the other side. This didn't take nearly as many cuts as the thickness is pretty even at this point. The uneven finish is due to the inner parts of the diameter not having high enough cutting speed for the inserts that I'm using, and this is a consistent problem I have with finishing larger parts on this lathe. Thickness opposite sides of the disc is the same to within a couple of hundredths of a millimeter, which is fine for this stage in the build. The part will need a proper finishing cut later once the edges are machined.